Absolute proof a second loop is impossible in the Collatz conjecture. I'm not going to explain the conjecture because I'm assuming that almost everybody watching this video will know what the conjecture is. For anyone who doesn't, I'll add links in the video description. And this is proof that a second loop is impossible in the Collatz conjecture. In this problem, because every rise or fall between consecutive values of x is even, it seems at first glance that there may be no way that we can find any kind of inequality between even and odd numbers which prevents a second loop. However, if we split every value from the first integer after 1 3x to the final integer in the next 3x into separate units on their own, for example from 22, which is 7 multiplied by 3 plus 1, to 33, which is 11 by 3, we get a net rise of 11. Or for a net drop, for example, 13 by 3 plus 1, which is 40, to 5 multiplied by 3, which is 15, we get a net drop of 25. Then each unit is like a link in the overall chain, and we always have an odd number as a net rise or net drop in each unit. Using these odd numbered units both individually and altogether as one chain, we find that indeed we can find an inequality which prevents a complete chain from being possible. We don't need to know or check any more individual values of x in any unique sequence because it applies to every possible sequence within infinity. I've managed to squeeze the essence into a 1-minute short video to try and capture the attention of the TikTok generation and busy professional mathematicians alike. It goes through it very fast, so some may need to pause it in steps to get it first time or rewatch it to get it. I also have a slower paced version which takes about 3 minutes in the video and a written version which I'll add the links in the video description. Absolute proof a second loop is impossible in the Collatz conjecture. Let's let x be odd and every 3x plus 1 be y, which is even. To have a second loop, every x must have all rises and falls in the loop cancelled to a net rise of 0 so it can return to itself. Where x is lower than the previous x, we cancel 2x in the drop from y to x with 2x in the rise from x to 3x, leaving a net drop of y minus 3x, which is always odd. Where x is higher than the previous x, we cancel 1x from y to x with 1x from x to 3x to leave a net rise of 1x, which is always odd. The lowest x in the loop, xl, would have a net drop between the final y, yf, i.e. yf minus 3xl, so we must get a net rise for all x's between 3xl and yf to be an odd number, the same value as yf minus 3xl, so they can cancel to 0. That needs an even number of net rises minus an odd number of net drops, or an odd number of net rises minus an even number of net drops, so overall odd. But then the second lowest x, xl plus 1, would leave a net odd drop between yf minus 3xl plus 1, but an even number of x between 3xl plus 1 and yf, which would leave an even net rise which can't cancel with yf minus 3xl plus 1, which is odd, so a second loop can never exist. This doesn't solve the Collatz conjecture absolutely because an eternal rise has yet to be proven, but it is part 1 absolutely proven, as anyone with basic algebra can see. Unfortunately, mathematicians can be very competitive, and some ambitious mathematicians clearly wish to keep this breakthrough to themselves. I'll explain how I know that in a minute. They're probably doing so in the hope that they can figure out the second part and make a name or a bit of cash for themselves. It's sad and disappointing, I know, and I don't like having to mention it, but that's the facts. So I would encourage any mathematicians, especially teachers, who love their colleagues and students more than individual fame or money, to share it. Because the proof that an eternal rise is impossible may be equally simple. It may also need only basic algebra and may be solved by an unknown mathematician, maybe even a child, who can spot the subtle but elusive solution. The reason I know at least some people are keeping this proof to themselves for unethical reasons is because no one whom I have sent it to so far will peer review or announce it in public. It has been sent and read by a few very famous mathematicians and editors. I know because my email read receipts came back as read, sometimes 2 or 3 emails in a row, all read. People know. Wikipedia editors say they won't allow it to go up on the wiki page until it goes through official channels, which is a catch-22 situation, and mods on forums, including Reddit, keep blocking it from going up or removing it when it does. So I'm hoping enough people who love their colleagues and mathematics more see the bigger picture and share it. Thank you for watching.